second part now. 25% weighs between 65 kg and k kilogram. Given k is greater than 65. So where will I draw? The mean is given as 61.4. So if I try to draw, the middle part here is 61.4. Logically my 65 is here, then my k has to be here. I think you will agree with this. So this probability here, it's given as 0.25. So because I'm writing my mean value here, this definitely has to be the x. What is my x? The weight. The weight I'm labeling as x. So let's write this information like what you always do. You will write like that. 65k 0.25. Simple. Then you will always change this into a z. So k minus 61.4 over 12.3. And then 65 minus 61.4 over 12.3. And then you will go and solve the number part here, and you're going to write the answer as (0.2927). This one you cannot solve, so you will keep it like what it is, equal to 0.25. Now it's the same image now. It's just that you're going to put a z here, and then the middle part is going to be 0. Nothing is changing here. This is the exact same 0.25. The area below the curve is exactly 0.25. This part, you know, it's 0.2927, and this is the part which you actually don't know. This is where the k actually being hidden. What is the coordinate for this z value? K minus 61.4 over 12.3. So at this point, how do I interpret this sketch? How do I do this? So it means you have to find the area of this whole region, because the table will read for you for the lesser part. But you are not sure, you don't know what to read because you don't know the k value. But you also know that another easier part here, that you can read from here. You can read for this part. How can I read for this probability? Because I have this value, right? So you don't know what is this, but you can find for this. This is easy for you. So technically what you will write? Those who are very good with the algebra, you will split them like this. Probability z less than k minus 61.4 over 12.3. Then you minus probability z less than 0.2927 equal to 0.25. Why do I do like this? Because technically I'm trying to imagine it like this. Yeah, this is the k part. Okay, I'll draw the 0 so that it becomes a scale for you. This is a k. This point is exactly this point here. This area you still don't know. Then what you're going to do? You're going to minus. The 0 is here, and the other part, which is this part here. So I'm going to draw here, which you know that it is 0.2927. This area you can find from the normal distribution table. So let's go and find. I'm going to cheat. I'm going to use the calculator and find this value. You can read your table meanwhile. It says the answer is 0.61512. So you can bring this over here, because this is area, this is also area. I can write them together. 0.86512. Now, do not take the k minus 61.4 over 12.3 and equate this to this one. Why you cannot do that? Because this is your z value. This is still your p value. For this particular p value, go and find the z. Go and find the z from the table. So if you find from the table, what will this equal to? See, z compare with the z, p compare with the p, apple with apple, orange with orange, like that. You cannot take this part and equate to the area below the curve. It's wrong. How can I just take one coordinate and compare it with the area? It doesn't make sense. So let's go and read for 86512. Where is 86512? Now the closest is this 1.1 and 0. I need another 8. So that is going to give me 4. 1.104. Solving that, .9792, approximately your K is 70.